Hello guys, and welcome to Algebra, and we're going to go into our next unit on here online. We're going to start day 1 notes, and we're going to be looking at quadratic functions. So you should have this worksheet pulled up to follow along while we go through this, and you guys can either write on it using Cami for a PDF, or you can print it off or keep the notes on a separate piece of paper. But these are the notes that are going to help you for your worksheet that is going to be due by Sunday. So what we're doing is we're going to start looking off here at a quadratic formula. And then from there, what we're going to do for there is we're going to look at some of the vocab for it to start with. So we're going to start off here with our axis of symmetry. So that's what I'm looking at right now. It's this dotted line that I'm drawing the red marks on that goes right down the middle, okay? And it must be an x equals equation. And it cuts the parabola right in half. So if you were to fold it in half, it mirrors each side. And there's a formula that you can find, which again, this will make a little bit more sense as we go through. X equals negative b over 2a. Then we have our x-intercepts. Right there and right there. So our x-intercepts are known as zeros or roots, where y equals 0. So in this case, this one would be 3, 0. And this one over here would be negative 1, 0. Then we have our y-intercept, and that is just where it crosses the y-axis. So there it would be 0, 3. And then our vertex, or our turning point, must be an xy coordinate. And it's either going to be the max or min, because sometimes with quadratics you will either see ones that look like this that I'm drawing on here, or this. So it's like the smile or the frown. So you can see it either way. Okay? So when I go through and I put this answer on here, you will notice that my writing is kind of a little sloppy just with this whiteboard that we're using to be able to take these videos. So if you can't understand something, please send me an email. Just ask. I know it's a little bit tricky here. Okay? So our vertex, the minimum or maximum point on a parabola, is also known as the turning point. Okay? In our axis of symmetry, the line of reflection that passes through the parabola's vertex. So we kind of see that right there above. When I look up here, you can see it passes right through. So like as you see right here, how it passes right through that vertex right there that I just circled in blue. And again, our equation for our axis of symmetry is negative b over 2a. And again, I'll go over that in a little bit. Our domain is the x values of the function, and our range is y. And then on our next page, x-intercepts, the points at which the parabola crosses the x-axis. And these are known as the zeros. You're going to really get to know that. Or roots. This is going to be, it's a T, a really big, I'm like starring it. I started to draw an arrow, but I turned it into a star. Really big part in our unit. Our y-intercept, point at where the parabola crosses the y-axis. minimum, the lowest y value, and maximum is the highest y value. Degree, it's the variables exponent in a polynomial. Our leading coefficient, the number in front of the variable. Exponent. It's a V. I know that's hard to, there you go. So the number in front of the variable's exponent. At any time, if you need me to slow down or something, you need time to write something out and I go too fast, just pause the video. Totally okay. So here, consider the quadratic function f of x equals x squared minus 2x minus 8. We're going to want to open up your internet, and we're going to want to go into a graphing calculator online called Desmos. So I'm going to show that right here. Okay, so I've opened up the browser, and I'll end up moving this in a minute, but we're going to type in Desmos and search for that. You'll see it. It's just loading. And you will see right here, Desmos graphing calculator. We're going to click on that. And then we're going to click this where it says Start Graphing. And you will see it gives you right here, and you can plug in your equation. So our equation on that one was f of x equals x squared, and then minus 2x minus 8. Okay, and you can see right here, it graphs the function right here for you, which is awesome. But then to pull up your table, you're going to click Settings, and you're going to click that little thing that looks like a table that I just pulled up right there. And then from here, you will get your values. If you don't see all the values, because like in our table it goes to 4, you just click the bottom one, and then you would type in 3, and it automatically gives it to you, and then again click the bottom one below it, and type in 4, and it gives it to you. And so you're going to put in all of those numbers right into your graph, right on here. So I'm going to get rid of this right now, just so you are aware. And then I'm going to write in our numbers that we just saw on there. So you know Desmos.com is going to be a great resource for you when you guys are doing sometimes your worksheets. So you're going to really want to start to get familiar with that. So we have 0, negative 5, negative 8, negative 9, negative 8, negative 5, and 0. Then we're going to graph it. So negative 2, 0, and then negative 1, 5, 1, 2, 3, 4, 5, negative 8, 6, 7, 8, negative 9. I'm going to graph it on the other side. Then you're going to draw your line. With your arrows. Once you have that, we can move down to the next part here. State the range. So remember, our range is our y values. So I'm going to start. So again, we're going to start here because this is our y. We're going to actually start from the bottom and go to the top. Okay? So here, the bottom of my graph, I'm going to show this in a different color in green, is right here. It's my minimum. It doesn't go any further. I don't have arrows pointing down. So, I have a minimum right here at negative 9, because remember we're looking at the y values, and then I'm looking and it keeps going up, 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 forever and ever, because those arrows would keep going, so it would be to infinity. Infinity and beyond. Then we're going to look at our domain. I'm going to show this with blue. Our domain is our x value. So that is where we read our graph left to right. You don't have to draw that arrow on your notes. That's just there to help you. So my arrows keep going and going and going forever and ever. Same thing here on both sides. So since it keeps going forever and ever to the left and keeps on going forever and ever to the right, it's from negative infinity to infinity. The next part here, over what domain is the interval increasing? So when I come up here, I'm going to show this right now in yellow. The only place it's increasing, because remember we read a graph left to right, is from positive 1, and we look at the x because they're talking about domain, so positive 1, because that's where this is at, and it to the right, and it keeps going because it keeps increasing because there's an arrow. So for here, it would be from negative 1 to infinity. State the coordinates of the turning point or vertex. So that's the bottom point right here where it meets that V. You can also see it right here because with a parabola on either side, it's the same number. So you'll have a middle point. It's 1, negative 9. Then we're going to draw our axis of symmetry on the parabola and then use the formula to write the equation. So what we're going to do here is I'm going to come on up. I'm going to do this in black so you can see it. And I'm just drawing my line. It's that middle line where it would fold over. Since it's a vertical line, it's an x equals equation, and we can tell it passes through x equals 1. So that will be my thing, but they also want us to find it using the formula. So what are we going to do? We're going to use that. Our formula is x equals negative b over 2a. So in our standard form for a quadratic formula, it looks like this. Y equals ax squared plus bx plus c. So whatever value for a goes in the place for a, and whatever our value is for b would go into b. Okay? So our equation in this is y equals x squared minus 2x minus 8. Okay? So here, since there's no number in front of that x squared, remember it's a 1. So this would be my a, and the negative 2 would be my b. Those are our important values here. So now I'm going to plug that into our equation. So it would be negative 2 over 2 times 1, which then equals negative times a negative is positive. So positive 2, and 2 times 1 is 2. 2 divided by 2 equals 1. So x equals 1 would be our answer for that. And just to make sure I'm right, I'm going to check up here. Yep, x equals 1. We're correct. Then our next one are x-intercepts. So what we're going to do here, our x-intercepts are also our zeros. We're just going to look at what are the points at where it crosses our x-axis. So I'm circling it right now in black, and I'm circling the other one because it crosses the x-axis 2 times. So there should be 2 answers here. So our point there is negative 2, 0, and 4, 0. You can also see that here in our table because it's where y is 0. So I'm going to write that down. So I have negative 2, 0, and 4, 0. What is our y-intercept? Well, our y-intercept is where it crosses the y-axis. So I'm going to look right on here. It's kind of hard to see on my graph because I was making lots of marks on it. But there is a point right there. I'm going to circle it. And that would be 0, negative 8. And I can also see it here on my table where x is 0. So be careful on that because it kind of can get tricky because you got to know where the zeros are on the table. I prefer to use the graph because you can see it. It's on the y-axis. So here, this is 0, negative 8. And make sure you got to put it in your point. So you got to put it as xy. Can't just write negative 8. Does the function have a minimum or a maximum value? So we're going to look at our graph. Our graph is a smile, right? So it looks like this, which means there's a minimum. So our minimum point. So we're going to say it's a minimum. And what is our minimum point? It's 1, negative 9. It's also always going to be the vertex. So this one has a minimum. So I'm just going to write min. And it's 1, negative 9. Okay. So now I'm going to go to the next part here. Determine the zeros from the graph. So remember, zeros are our x-axis, so it's where it crosses the x-axis. So if right there, it would be 1, 2, 3, 4, negative 4. So it would be negative 4, 0, and 2, 0. Okay. Exercise 3. If the zeros of a quadratic function are -3 and 5, what is the equation of the symmetry, axis of symmetry of f? So this one's a little bit tricky. So if you have our zeros, that means it would be -3, 0, and it would be 5, 0. Okay? The easiest way, I think, for us to figure it out is write out the numbers between -3 to 5. So -3, -2, -1, 0, 1, 2, 3, 4, 5. And we're going to play the knock it off game. So knock it off, 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 knock it off. And it's the one right in the middle. So that means x equals 1 would be your answer. Okay? The reason why is because on a parabola, your points are, everything is symmetric. So that means this point matches this point. So it's going to be the same distance to your axis of symmetry, your turning point. Okay? So that's why that works. So last question here. Okay? So for exercise 4, an expression of the 5th degree is written with a leading coefficient of 7 and a constant of 6. Sorry, I don't think I read the beginning. The expression of a 5th degree is written with a leading coefficient of 7 and constant of 6. Which expression is correctly written for these conditions? So what that means, okay, we kind of talked about it before, is our standard form. Y equals ax squared plus bx plus c, okay? In any case, no matter what your exponent is, how many times there's the highest exponent means how many times it's going to hit your x-axis, okay? So if it's 2, it's going to be, you'll have 2 zeros. If it's 5, you'll have 5 zeros. 4, 4 zeros, and as always, okay? So here, I put squared because that's going to be what you're going to commonly see, but that's really just your exponent. So it's your highest leading exponent, so degree, that represents where the degree would go for your highest degree. So here, 5th degree, in that place of where I put squared, it should be a 5, okay? Leading coefficient is your A. So leading coefficient. So I'm just going to write leading. And constant is your C. And it's just a number. Shouldn't have a variable with it. So here, 5th degree. Okay, this is a 5th degree. And that one has a 5th degree. So I can cross off 2 and 3. Next part, leading coefficient of 7. Well, that doesn't. This one does. I can cross that off. But let's just make sure it has a constant of 6. And it does. So my answer is 4. So make sure you have these notes done, because then on Wednesday when I see you, I would like to be able to do worksheet 1 with you, so you can finish that. Okay? Great job, guys. Bye.